Hey everyone, we've been learning about the periodic table. It's a list of all of the atoms that are in the world around us. And in our last lesson, we saw that it contains all sorts of helpful information about those atoms. In this lesson, we'll take a look at the organization of the periodic table. It turns out that atoms that are grouped together have common properties. So just what are these groups and what are these properties? Let's take a look. So first, let's compare metals and nonmetals. Here you see two examples of metals. This is iron, which is Fe. And that is right over here, element number 26. It is a metal. You'll notice it starts with Fe, which is a little strange. Sometimes elements on the periodic table are abbreviated with letters that we wouldn't expect. Sometimes they make a lot of sense, like C is carbon, totally makes sense. The reason for this is that not everybody that contributed to the periodic table spoke English, and so sometimes those abbreviations are abbreviations for that material in another language. The metal you see down below here is calcium, Ca, an abbreviation that does make sense. And the properties of metal that we should keep in mind are that they are shiny, so that is they reflect light well, and we see that for both calcium and iron. They're malleable. That means that we can shape and form them how we'd like. So we can hammer them out into flat sheets, and we can form them into nice cubes. We can shape them however we'd like, and they won't fall apart or break. Then lastly, we should know that they're good conductors, and they're good conductors of heat and of electricity. So heat and electricity. That means if you want to make a wire that conducts electricity, make it out of a metal. And you'll notice most of our wires are made out of metal. I'm going to go ahead and say all of our wires are made out of metal. And if you want to make something that conducts heat well, you make it out of metal. So you have an iron pan that conducts the heat well to warm your food. Now, when we look at where they are on the periodic table, we see that this periodic table is color-coded such that metals are in yellow. And that color code varies based on what periodic table you're looking at. If you imagine a stair step going from boron way up here, this kind of forms the dividing line between metals over here on the left and non-metals over here on the right. So over here are non-metals. And we'll take a closer look at those in just a second. So the metals are in yellow here. The only exception that we should really put on the far side of the stair step as the dividing line is hydrogen. Hydrogen should really go way over here with the other nonmetals. It's a gas. So that's the only one that's not really grouped correctly by this left-right distinction. We also notice this piece of the periodic table down here. And it's placed down here because it's so long, it actually should go right in where that red square is. And if we had it, it would make this periodic table really large. And so they always kind of just offset it down below. And so it's also on the left side of the stair step. Okay, so that's metals. Let's take a look at nonmetals. Nonmetals are dull, that is, they're not shiny, so they don't reflect light well. They're poor conductors. They don't conduct heat very well, they don't conduct electricity very well, and they're brittle. So here we see a pile of sulfur. You can see that if I try to shape sulfur, all that happens is it falls apart. That's what we mean by brittle. And on this periodic table, they're in the light blue on the far side of the stair step. Now, there are some things in between metals and nonmetals, and they fall right on our stair steps. They're shown in this purple color, and they're called metalloids. They have materials that are between metals and nonmetals. And that's not surprising then that they lie between the metals and nonmetals on the periodic table. We've organized this table in just such a way that the properties tend to vary as you move across it. And so that's really useful because that means if two elements are close together, they tend to have similar properties. And so at the line of metals and nonmetals, we find things with mixed properties. They're also semiconductors. That means they conduct under some circumstances and not others. That's really important because computers turn out to rely on things that conduct sometimes and not others. In fact, this chunk down here is silicon, one of our semiconductors and one of our metalloids. And it conducts electricity in some cases and not in others, and is at the heart of our computer technology. It also has mixed properties. Silicon, you'll notice, is shiny. You can see the light being reflected there, but it's also brittle. If you hit that with a hammer, it will shatter into many, many pieces. Okay, next we're going to start taking a look at columns on the periodic table and talk about their special properties. First up are the noble gases. They're called noble because they're very stable and unreactive. Notice that they all fall in one column. So all of those in that one column have similar properties. Again, you see how the periodic table is grouped by properties. We would call this group 18. So you can notice that 18 up there. And so group 18 elements are noble gases. They're really stable and unreactive. So for that reason, they're actually used when you want to preserve something. So down here, you see the preamble to the Constitution, and it's stored in argon, Ar, one of our noble gases, which you see right there. And so if you go to Washington, D.C. and take a look at the Constitution, it'll be placed in a case surrounded by argon, and that's to preserve it so it doesn't deteriorate. If it were in oxygen, which is not a noble gas, it would actually deteriorate because oxygen is actually pretty reactive. It'll react with that over time. All right, some other properties of the noble gases. They're odorless and colorless. And what that means is that you can't see them, right? And you can't smell them. And so, for example, there's argon in the air all around us. 1% of the atmosphere about is made of argon, but we can't differentiate it from the rest of the gases in the atmosphere. And this sort of goes without saying, but they are in fact gases. They are typically gas at room temperature and the pressures we typically experience. Okay, now let's go to the opposite side of the periodic table, to group 1, with the 1 on top of it. These are called alkali metals. They're shiny, and that's because they're a metal, but they're soft, and that makes them unique amongst metals. So if you were to hold them in your hands, you could press them and change their shapes. Obviously, that's different than iron, which needs a much greater force to deform it. And they're also highly reactive. So down here in this vial, we see sodium, which turns out to be abbreviated Na. That's one of our alkali metals. It's right there. And it's quite soft, and it's also quite reactive. That's what this explosion is showing over here. This is sodium mixing with water. So if I take sodium metal and I mix it with water, it releases tons of energy, and sodium actually becomes Na+. So sodium loses an electron in a process we call ionization and becomes Na+. And Na+ is actually the sodium that we typically see around us in the world. So for example, table salt contains Na+. And that's not super reactive once the electron's been removed. But if you have it in its pure metal state before the electron's been removed, it's super reactive. And that's typical of all the elements in that alkali column. If we go one group over on the periodic table, we get to the alkaline metals. They're still shiny and they're still soft. Why is that not surprising? Well, because they're next to the alkali metals. And so they actually have a lot of properties in common with them, but they also change a little bit. They're just somewhat reactive. So this is calcium. We've seen that calcium picture before, and that's one of our alkaline metals. And it's somewhat reactive. If I drop calcium metal into water, it will cause it to start steaming, but it won't cause an explosion. So it's reactive, but less reactive. So this is how we can categorize elements on the periodic table. And there's many more categories we could talk about. So this is just a rough introduction to give you the idea that elements that fall in similar columns have similar properties. And that's really useful to us as chemists because we can look at a column and know that the elements there are going to have similar properties. So for example, you'd expect all of these to have similar properties, and in fact they do. Those are the halogens. Fluorine, chlorine, bromine, and iodine all have quite similar properties. And so this principle applies to lots of the groups that we haven't yet gone over, and we'll continue to learn about the periodic table and periodic trends in future videos. Hey, hey.